Hey guys, Mr. Backerberg here. In this video, we're going to look at trig functions of quadrantal angles. So as we're talking about these quadrantal angles, let's define what a quadrantal angle is. So as we're looking at our x and y axis, our axes split our grid up into these different quadrants. So a quadrantal angle, as we're looking at an angle plotted out in standard position, is an angle that lands on one of the axes. So remember, we always start along that positive x-axis, and if we were rotating our angle around and we stopped at this y-axis right here, that's an example of a quadrantal angle. And this actually ends up being a 90-degree angle in there. Now I'm going to draw out all of our quadrantal angles, and I'm going to use different colors so that we can distinguish them. So let's start again in standard position, but instead of stopping at the y-axis, let's say we rotate it around all the way over to our x-axis over here. That's another quadrantal angle, and that's 180 degrees. Then if we rotate past there, so again starting along this positive x-axis, rotating around but going down to this negative y-axis down here, that's a 270-degree quadrantal angle. And then our last quadrantal angle is, as we're starting along this positive x-axis, we could make a trip all the way around, and that ends up forming a full circle, so that ends up being 360 degrees. Now I didn't mention it earlier, but 0 is a quadrantal angle as well. If we start along this positive x-axis and don't rotate at all, then that's a 0-degree angle. So these angles here are our quadrantal angles. So let's look at one of our quadrantal angles, and we're going to do a little trig with it. We're going to focus on a 90-degree angle right now. So on my grid, we're going to start in standard position, so along that positive x-axis, and rotating around so that we form a 90-degree angle in there. Now we're going to be looking to work with an ordered pair along this y-axis, and something's going to hold true about every single ordered pair on that y-axis, and it really won't matter which point we choose. So I'm just going to approximate a point right there, and I'm going to say that that's the point 0, 3. Every single point along that y-axis is going to have an x value of 0 because we didn't go anywhere left or right. We only went up a certain amount of spaces. So as we're looking at doing trig with any ordered pair in there, hopefully we're going to notice a pattern as to what's happening in here. Now, as we're using this ordered pair, we are going to need to find our r value. And remember, r is the square root of x squared plus y squared. But we just got done saying for every single ordered pair along this y-axis, that x value was going to be 0. So that x squared in there really doesn't matter. What's going to end up happening in here is this r value is going to be whatever distance your point is away from the origin. So since we've got a y value of 3, that would mean that this point is 3 spaces away from the origin. So our r value ends up being 3 in here. Now if I wanted to do the sine of this 90-degree angle, remember for the sine we go y over r, so the y value is 3, and the r value we just said was 3, so the sine of 90 degrees is 1. If I wanted to do the cosine of this 90-degree angle, remember cosine is x over r, this has got an x value of 0, and we said the r value was 3, and when we take 0 divided by 3, we get 0. Now if I want to do the tangent of 90 degrees, tangent is y over x, so our y value is 3, but our x value is 0. And this is going to give us a problem because we don't like to have 0 on the bottom of a fraction. So this tangent of 90 degrees is undefined because of that 0 on the bottom. Now we can also do our reciprocal trig functions as well. So remember the cosecant is the reciprocal of the sine, so that's r over y. So here the r value is 3 and the y value is 3, so the cosecant is 1. If we're doing the secant, remember that's the reciprocal of the cosine, so that's going to be r over x, so we get 3 over 0, but we can't take 3 and divide it by 0. You can never divide anything by 0, so this is undefined. And the cotangent of this 90-degree angle, cotangent is the reciprocal of the tangent, so that's x over y, so we're going to get 0 over 3, which is going to give us a cotangent value of 0. Now, I said that I was hoping that we would notice a pattern happening in here. So let's say I picked a different point. Let's say I picked a point up here and maybe it was 0, 5 as my ordered pair. The r value is still the distance away from that origin, except now it's 5. So as we're building this sine fraction, we're always doing that y value divided by the r value. And here the y value and the r value are always going to match up. So the sine of a 90-degree angle is always going to be 1, regardless of what ordered pair we're dealing with. So typically we use the simplest ordered pair that we can come up with along our quadrantal angles. So we actually could have used the point 0, 1 in there, and then that's going to give us an r value of just 1. And that makes finding these trig values a little easier. So let's look at a different quadrantal angle this time, and let's look at a 180-degree angle. So 180 degrees, we're going to start along the positive x-axis, and we're going to rotate around. 180 degrees ends up landing us on the negative x-axis. Now, we just said that we want to use the simplest ordered pair that we can come up with. So going left along this x-axis, we're going to need a negative x value. And the simplest negative x value is -1. And as far as our y value, we didn't go up or down at all because we're on that x-axis. So the y value is going to be 0. So we're going to use this ordered pair -1, 0. And as far as the r value goes, we said with these quadrantal angles, it was just going to be how many spaces we were away from 0. So we went left 1 space. So even though my x value is negative, my r value is just going to be +1. So now if I want to do the sine of our 180-degree angle, I take the y value of 0 divided by the r value of 1. So the sine of 180 is 0. If I wanted to do the cosine of 180 degrees, I take the x value, which is -1, divided by the r value of 1, so the cosine of 180 is -1. As far as the tangent of 180, we take the y value of 0 divided by the x value of -1, so the tangent of 180 is 0. Now, if I'm doing the cosecant of 180, cosecant is the reciprocal of the sine, so I'm going to get 1 over 0, but we can't have 1 over 0, so this is undefined. For the secant of 180 degrees, that's the reciprocal of the cosine, so we're going to get 1 over -1, so we get -1 as our secant value. And then for the cotangent of 180 degrees, that's the reciprocal of the tangent, so we're going to get -1 over 0, and we can't have -1 over 0, so this is undefined. That's going to be it for this video. Thanks for watching.